Hello everyone. In this video, I would like to share with you what is probably the most surprising problem I have ever encountered in probability theory. Although the problem itself isn't particularly difficult and can be understood even by a school student, the conclusions that follow from it are truly striking. So let's consider an exam format that was once used, at least in Soviet Union. This is so-called exam by tickets. So you come to the exam and in front of you, there is a set of tickets. The questions contained in these tickets were given to you in advance, so you can study them in advance. But now you do not know which questions are in which ticket. You randomly draw one ticket and must answer the questions written on it. Suppose that there are 8 tickets, here they are in total, and you have studied only 5 of them. So it's very easy to calculate the probability that when choosing a ticket at random, you will draw a lucky one. So let's say this is lucky, 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 and the 3 others are unlucky. So lucky one means that it's a ticket you have studied. If you draw such a ticket, you will answer well and probably receive a good or excellent grade. If, on the other hand, you draw an unlucky ticket, this means that you will fail the exam, unfortunately. So first step, the easiest one, is to find out the probability of taking the lucky one, the lucky ticket. So all the tickets are equally likely to be chosen, yet I don't know which one is lucky, which one is unlucky, but I can estimate the probability of having a lucky ticket. So there are 5 lucky tickets, and I choose them out of 8 in total. I choose 1, but there are 8 in total. So 5 are favorable outcomes. So the probability is 5 over 8. Okay. So now I want to change the scenario a little bit. Imagine that another person, my classmate, is going to take a ticket in front of me. That is, he wants to be the first to choose the ticket. Yep. So then, to analyze this situation, I have to use one of the easiest and most effective ways of analyzing problems in school probability theory. It's tree diagram. Yeah. So this is the first person to choose. It's not me. And this is the second person to choose a ticket. It's me. So the first person to choose, he or she can choose my lucky ticket or take my unlucky ticket. So lucky ticket can be taken with the probability of 5 over 8, and unlucky can be taken with the probability of 3 over 8. Of course, I should have stipulated that if a ticket is taken from this set of 8, it will never be returned back. So I am the second person to choose a ticket. So if the first ticket was a lucky ticket, then I have to take it into account. So the probability to take a lucky ticket for me then it's 4 lucky tickets now, and there are 7 tickets overall. So 3 over 7 for unlucky ticket. But if the first ticket drawn was unlucky, so there are 7 tickets totally, and it's still 5 lucky tickets. So the probability for unlucky tickets is 2 over 7. So once I have filled the tree diagram, so I can find the probability that the second person, it's me, to choose the lucky ticket, probability of lucky ticket. It is, so as you can see, there are 2 branches of this tree that lead me to the lucky ticket here and here. So it's 5 over 8 times 4 over 7, or the second branch, 3 over 8 times 5 over 7. Okay, the common denominator is 56. So this pair gives me 20, plus this pair gives me 15. So 35 over 56. And after reducing this fraction by 7, it gives me 5 over 8. Yeah, this is the most surprising conclusion, because you can see the probabilities of taking the lucky ticket are the same. Yeah, it's amazing. So I can show you even more interesting situation when there are two people in front of me. They want to take their tickets and they make their choices at random, of course. So the tree diagram will be a little bit more complicated, but still easy to analyze. So I just can copy the first two outcomes. So lucky, unlucky, lucky, unlucky, lucky, unlucky. So lucky, unlucky, lucky, unlucky, lucky, unlucky, lucky, and unlucky. So it's 4 over 7, 3 over 7, 5 over 7, and 2 over 7. Okay, so let me find out the probabilities and fill in the tree diagram and then show you. So I filled the probabilities and can analyze the problem absolutely the same way as we did it in the previous point, in the previous part. So I want to, okay, let's say this is the first person to take a ticket, this is the second, and this is me. Yep, the third person. So I want to end up at lucky, 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 and I consider all the branches that lead me to the right outcome at the end. So probability of lucky ticket is 5 over 8 times 4 over 7 times 3 over 6. So here is the branch I'm analyzing, plus, because it's or, 5 over 8 times 3 over 7 times 4 over 6, or 3 over 8 is the third branch. Here it is. 3 over 8 times 5 over 7 times 4 over 6, plus 3 over 8, the last branch, 2 over 7 and 5 over 6. Okay, I can see the common denominator is 8, 7, 6. So the first triple gives me 60. The second triple gives me 60 again. The third triple, oh my God, it's 60 again. And the last one, the last one isn't 60. I'm surprised. So it's 30 plus 30. It is equal to 210 divided by 8, 7, and 6. So I can divide by 7. So 30, right? And I can divide by 6. This gives me 5. Oh my God, it's 5 over 8 again. So you can see that the result, it doesn't depend on my position in the queue, right? So it doesn't matter whether I'm first to take a ticket, second, or the third. And even if we consider an extreme situation where not one or two people, but 7 people step in front of you, so that you approach the tickets last, when only one ticket remains, it may feel as if you have no control at all over which ticket you get. It seems that the choice is already made. It was already been made for you. However, that ticket was chosen in exactly the same random way as all the previous ones, and all earlier tickets were drawn randomly, and therefore it's easy to see that the probability, and it's easy to guess that the probability that the very last ticket, the one left by 7 people before you, is a lucky, with the same probability. It's still 5/8, 5/8. This remarkable problem was also it has also a deep philosophical meaning. It can say that the person standing next to me in line, in queue for the exam, is also experiencing the same for the first time. We usually say he's experiencing this life for the first time and taking this exam for the first time. So these people, they're not trying to help me or sabotage me in any deliberate way. They simply have their own goals. Just like me, they want to pass the exam. So without realizing it, such a person may either help me or interfere with me. But if you truly want to increase your chances of passing the exam, the most reliable strategy is very simple. Just study more tickets. Yes, study more tickets. Let me write it down. Yep. So this is the main philosophical insight. People around us, some of them may help us in life, and some may get in our way. But in the end, the result depends only on you, and only on you, at least on average. This is exactly how it works. So it's a really fascinating problem. I hope it makes you think, and that you will appreciate the philosophical meaning that I see in it. So goodbye, and see you in next problems and next ideas. Bye bye.